First of all, just a little bit about the contents of the presentation. So initially, very briefly, in a few points, I'll just go through the things that I need to do in GSoC. Like GSoC is a program in which it is not only about the technical project, but also about learning how to collaborate with others in an open source environment. So I'll talk a little bit about that in the first topic. Then in the second topic, I'll talk about the converter which is to be made in Python, which will take data sets in the format of comma separated values or in the format of Excel data sheets and then convert it into an XML framework. Then the third one will be talking about GraphViz and Gephi and the graphical XML formats like GML or graphical ML, the formats which are basically compatible with GraphViz and Gephi for representation. And I'll also be sharing a few screenshots of Gephi which I had run today. Then in the fourth topic, I'll talk about community related, how to get involved with the community and what work I plan to do under that topic. And lastly, I'll talk about documentation and how I plan to keep track of progress and all that. So should I begin?
Yes.
Okay. So, like I said, so GSoC is a program which is a technical program and a like working code needs to be there. But apart from that, some other things that I must keep in mind is that the end aim should not only be the project, but also the fact that I must come out of the program as someone who knows how to collaborate in an open source environment and specifically in the case of our project, it is also an open science project because not all projects are open science. Some are only open source, but our project is not only open source but also open science because there is sharing of research related data and in our organization there are many researchers and basically it is a science related project. So that is one. The second thing which I will talk more about when I come to the Python related part is that there are certain doubts that I have related to the process of embryogenesis, which I will clear up in the coming weeks because without that I won't be able to make complete sense of the data sets that were shared. And the third thing is apart from the Python and XML related work, like you had suggested the other day, I need to make a Jupyter notebook for sharing codes and results. And in Overleaf, I think that format is known as LaTeX format, right, for writing research papers.
Yes, we'll use LaTeX. We're going to use Overleaf as one of the templates in Overleaf, and that's done in LaTeX.
So in case we plan to write a research paper based on the project, then I'll need to use Overleaf and write everything in LaTeX format.
Yeah, we're gonna work from a template. Yes. And then.
Okay. So yes. So first, I would like to share about the Python codelet that I had made. So just give me a second. Let me show my GitHub repository. So this is the fork that I had created from DevoWorm. So like I had discussed the other day, I made a branch on it called issue 8 because this is related to issue number 8, which was writing a Python codelet. So I haven't officially filed a pull request for this because I thought I'll first show you what exactly is there in the branch. So there's a folder in which basically there are 3 files, the Python code, then there is a small comma separated value file and there is a file called issues. So I'll tell you what this is. Just give me a second. Okay. So I think about 2 months ago, if you remember, you had shared a few data sets with me, which I'm opening up right now.
Okay.
These data sets.
Oh yeah, I remember those.
Yes. So now I was going through these data sets. So as you can see, like let's say these cells that I'm highlighting right now, in all of them, the format of the lineage name is same: AB parent, then space, and then the path of growth. But now, if you go a little further down, here the format is a little different. Here, instead of a space, P1 is written, and then there is a dot, and then APA is there. So the way in which these two lineages have been written is a little non-uniform. So what I did was that I copied a small part of that data set, and in a comma separated file, I only copied a few entries, just to take a small sample and test my code on it. So in this, I made sure that all the entries that I've taken are in the same format, so that everything is uniform. So yes. So now can you see the presentation again?
Yes.
Yes. So now in this, like, this is not the official code, but like I had said, I'll just write a small code to get a feel of the project. So I took that small CSV file here, which you can see on the left, and then a very small code I wrote to basically just read the file like you can see in line number 3. F is open sample data.csv in read mode, and then I just read the file, and basically I just operated on this the second line, ADFL line. Can you see the ADFL line number 2?
Yes, I can see the.
Yeah. So
yeah, I
in
can
the
see everything. Yeah.
yeah, so in the you can see basically, like, I just basically kind of just separated the different parts, the name differently and parent differently and lineage
Hello.
code from line 1 to 4. The zeroth index to the fourth index is the name of the cell, and from 6 to 8 is the parent. But now here what we'll notice is that all the cells have a 4-digit name, and then the parent is also AB for everyone. So this was just a common code. But now when we take this entire data set, so what I realized was that there will be some issues when I write the proper Python code. So those issues have been discussed by me, written down here in my branch in the issues file. So there are 4 issues that I think I need to take care of. So so in this issues, the third line, there is a need to standardize the input comma separated values file, because here there is a lot of non-uniformity. Like I said, here the parent name is there, and then there is a space, and there is the developmental part. But in this case, there is the parent name, and then there is a dot. So before I begin writing the proper Python code, I need to standardize this data file, or I need to write a Python code in which the code will take care of this. Basically, the code will check whether there is a space or a full dot, and accordingly, it will make the separation.
Okay. Yeah, the one reason for that is that the ones with a dot are adult cells, and the ones with the space are
Okay.
embryonic. I mean, we can go through the list and, like, I can tell you which ones are which. I mean, yeah, it's a good start, though. We have a good, you've parsed the document so that it's all in the proper format that we're going to use for this.
Yes, just give me a second. Let me just write it down. So the one with dots are adult cells, and the one with spaces are embryonic cells.
Well, the ones that you showed me, like the P1 dot, are adult versions. Okay. We'd have to go through the list, though, to see what each one is. Okay. I don't know exactly. Okay. You just showed me that little part of the list.
This one?
Yeah, that one. So, well, the whole table, but yeah, we'll go. Well, yeah, that table. So, like, Yeah, I believe the ones with the dot they're going to be adult cells. See, they put the adult name on the left in the cell column, and then the lineage name is like, sometimes it's like an embryonic lineage, sometimes it's a post what they call post embryonic lineage, and so
Okay.
we have to go through those, and I can tell you which ones are which.
Okay. So, like, should we go through all of them right now? Like,
No,
there
we
are.
can we can go through the presentation, but let's continue with
Okay.
the presentation and then.
Okay, fine. So, yes, so that was an issue that I realized that I need to take care of. So going back to point number 2 in this slide, embryogenesis related doubt. So this is what I meant. So basically, as I write more code and as I come across such issues like what is the difference between a dot and what is the difference between a cell, and why are certain cells written in a certain format in the name. So as and when I have more doubts and as I get them cleared from you, the embryogenesis process related doubts, I think uh, as I keep doing that, the code will basically keep taking care of those issues basically. And yes, so the uniformity is key basically. That is what I'm saying. Now, point number 3 in this is that I need to integrate all the data sets together. So now, going back to the data sets. So one data set was the one which I just showed. Now, apart from this, there is another differentiation tree related data set in which the XYZ coordinates and the XY plane angle of all the dotted cells were listed down. So, can you see it?
Yes, I can.
Yes. So now, for these cells, the parent cell and the daughter cells, basically we have two different tables. In one table, we just have the lineage name and the description, and in this table, we have the exact coordinates of where they were formed and all that. So basically, the same cell has different information in these two tables. So I need to make sure while writing the code that information is extracted both from both the files. So if there is a cell, complete information must be there about it. So from the first data set, we can take the information related to the description and the lineage name. And from this one, I can take information related to the XYZ coordinates and what daughter cells it has and what was the parent cell and all that.
Okay.
So yes, and after all of this is done, like after the all the cells have been taken care of and I have a proper running code in which in input I give the data sets and in output I get a proper detailed XML framework for each and every cell with each and every possible information about the cell from parent cell name to daughter cells and whether it has daughter cells or whether it does not have any daughter cells and the description and the XYZ coordinates. When all this information is there together in a proper XML format, after that, the next step would be to convert it into a necessary graphical format, which I'll come to after this. So, on Thursday when we had that call, so I told you that I'd be running Jeffy and GraphViz. So I still haven't run GraphViz. I'm trying to, get it like to work. So I ran Jeffy and it had a dependency on Java, so I had to first install Java and then I ran it. So there were some cool features about it. So I just ran one example file which they had already given. So uh, here is the file. Yes, so I think less measurable is I think some movie or something or some play. So there is a .gml format file. So in that, like on Jeffy's official webpage, they had given this sample data set to play with. So basically, in this format, the graph is there and all the nodes and IDs are there with the labels. And now, if we go a little down, these edges have been defined in this way, uh, here when the nodes are defined, let's say eponine has been defined as id number 41. So if there is any so if there is any edge which will connect this node, app node with node with some other node, then it will be like this. So here, as you can see, these three edges are connecting Apo9 to some other nodes. So the format in which they've given it is this edge. The source is Apo9 and the target is 24, which probably is some other character's name. And the value is, to my understanding, I think the value is basically the weight of the format. So now if we specifically just consider this edge, source 41, target 24 and value 2. So 24, I think. So 24 is another character's name called MME Thenandier. So basically that edge is connecting this character to Apo9. So I ran it and let me show some outputs which it had. So this was the initial output which was generated by default. Can you see?
Yes.
Yes. So now there were some good features about Jeffy which I realized when I was playing with the giraffe. So now here you can see that the red node probably represents some main character which has the most number of connections with other clusters and characters. So now in every cluster you will see that there are a couple of nodes which are larger than the others. Now let's say in the blue cluster there is a large blue dot. In towards the right in the green cluster also there is one large green node. So there is one good feature in Jeffy is that you can move around these nodes by clicking them. So like in the next picture you will see the clusters are still the same, but I've moved just the main head nodes from every cluster to some distance away, just to understand how the head nodes are connected to their respective clusters. So again, going back to the previous image, this was the previous one, and after dragging the head nodes, this is the new one. So basically, Jeffy it helps in like you can basically move the nodes around, and then there are some nodes in the center which are very small which we can't see, so we can also zoom into them and see them clearly. Like here, if you see, we can't see things properly, so now if we zoom in we can see it properly, like the very small nodes and how they are connected and all that. So because of these reasons I liked Jeffy, and now in our embryogenesis dataset there are 1,000 cells. Of course, if we consider any given like time frame, not all the cells will be there. All the cells might not be there together because there might be some cells which haven't been formed yet, which will form in the future. But my point is that at any given point of time, there will be a lot of cells. So we will need something like Jeffy, which can help us move around the nodes. So this is what I liked about Jeffy. Like the features are good. I still haven't run GraphViz. I'll see what I can do about GraphViz. And another good thing about Jeffy is that it runs on Windows as well, and as well as Ubuntu. So that is what I saw. Do you have anything that you would like to share light on about this?
Not right now. If we could go through the rest of the slides just quickly, because we're already at the end of our talk time.
Okay. So now community related things that I need to keep in mind is that every alternate Wednesday we have an office hours which I attend, and community channel check-in which I think also happens every Wednesday. So apart from this, I think a month ago there was another volunteer of the OpenWorm called Michael Cooper Stakowski. So he had set up a repository on this link, OpenWorm Beginner's Guide, and we had decided to collaborate together and work on making a guide for newcomers to OpenWorm. So we never really began doing anything on it, and that repository is still empty. So I plan to do something about it, and like kind of decide a proper workflow that newcomers can go through to understand what OpenWorm is all about. Because the thing is that like when different volunteers join OpenWorm, they come from like different backgrounds. Some of them are students who are interested in the coding aspect of OpenWorm, and some of them are researchers with PhDs who are more interested in the science related part. So at least for the newcomers who are students and are mainly interested in helping out with coding, so for them we can like have a proper beginner's guide. So I plan to collaborate with them on that. And for documentation and progress and updates, I think the three important progress reports that I need to file are: the first is the web-based tracker, which is there on my blog, arnab196.github.io. Then, apart from that, I need to give weekly updates on trelliscience.com on that thread which has been started, GSoC creating weekly updates. And apart from that, we have a weekly call every Thursday. And yes, and apart from that, like evaluations and all other GSoC related whatever deadlines are there, I need to keep those in mind. And for documentation, like you had said, readme.md, the markdown file of the main repository will be used. And to do this week, so I need to figure out more about what exact information I need to know about embryogenesis, because there are still certain things that I'm not very sure about the embryogenesis aspect. So whenever I have doubts, I'll definitely let you know. Like if I can't understand the meaning of the naming convention of a cell, or why cells have been named in a certain way, like that example which I had given you, the space and the dot, the lineage name, why it was different. So I'll let you know if I have any doubts related to embryogenesis. So now another thing that I need to do is I need to run GraphViz to decide whether to use it or Jeffy, because I've run Jeffy and it looks good for the application that I plan to make. And I haven't yet implemented Jupyter, so I'm going to do it. So that this is what I plan to do this week. And yes, for the Python code, now going back to the Python code, so this is a very trivial Python code. Basically, there is very little programming that was done here. This was very mechanical, and basically I just extracted the lines, and whatever indexes I needed to extract, I've used them. Like you can see in line number 14, line number 21, and line number 28. Whatever indexes I needed, I just extracted those parts of the string basically. But for 1,000 cells, I can't mechanically do it for all 1,000 cells. So for that, I need to use loops and conditions and all that. So basically, coming back to this, so yes, now the main work on the Python code will begin, and whatever inconsistencies are there in the CSV file, I'll kind of iron them out and start building the Python code. So yes, that's it from my side.
Okay, well, thank you. Thank you for presenting.